and therefore that is the cause. So, without wasting the time, I guess my screen is visible to each and every one of you. Let us start. My topic's name is hands-on software-defined networking with Mininet emulation tool. So what we are going to cover in this topic is traditional networking. Then we'll be discussing about overview of SDN, architecture of SDN, and then we'll be seeing that what is the comparison of your SDN with the traditional networks, what are the different SDN controllers which are available. Then we're going to see the most important project which plays a very vital role to support this SDN, that is your OpenFlow project. Then advantages of SDN, tools which are used in SDN, and current research directions in SDN. So before we jump into SDN, let me make you clarify what is this computer network and types of computer networks and why these networking devices plays a significant role to support this computer network. So computer network can be explained as a cluster of multiple nodes that are linked to each other. So this interconnection among different nodes uses multiple paths and links to share the information, data, resources, and various applications. The links for sharing and exchanging the data or resources can also be established through cabled wire. So there are different types of computer networks, such as your local area network, metropolitan area network, wide area network, depending upon the geographical locations and areas. To support this computer network, we have got different types of network devices. The very first type is a router. So router is a networking device that is used to forward the data packets among different computer networks, maybe from your one wide area network to another wide area network. Then we have got hub. So it's a layer 2 device of OSI model, which sends the frames of layer 2 to all the devices connected to a network. So hubs are usually used by your local area network to connect to its all the segments. Then we have got another networking device, which is your switch. So a switch is another important networking device, which is commonly known as intelligent hub. So it is also works on layer 2 of OSI model, but it maintains a record of all the media access control addresses of all the connected devices. Then we have got another networking device, which is called as bridge. So this networking device provides connecting link between two different networks. So they work in a very much similar way of hub repeaters, but the only difference is that these bridges are used to broadcast the data to every single node which is connected to a network. Now you might be wondering why.
Sumit sir, 1 second. Sorry for the interruption. Actually, I couldn't see the screen rolling. Okay, now the PPT is actually moving. Sir, can you please put it in F1 mode?
Ma'am, I have already put it in the slideshow mode. Is it visible now?
No, sir, it's not in slideshow mode actually.
Okay, just give me a second, ma'am. Is it okay now, ma'am?
Yes, sir. Now it's in slideshow mode.
Okay.
Sir. Thank you, sir.
So you might be wondering that why am I telling you this all about networking devices? So the main important role of these networking devices is to carry the traffic from one place to another. And traditionally, these routers, switches, and hubs are vendor specific. That means companies own them. For example, if I talk about if I get to purchase a router from your Cisco, then Cisco would have incorporated all its configuration into that particular router. And in any case, if I want to change or alter that, customize that changes in that router, then I won't be able to go for that. So I need flexible networking devices through which I can forward the traffic from one place to another. And hence, there are numerous disadvantages in your traditional networking. You can see in this figure, I have taken 4 different networking devices, and each and every networking device is comprised of management plane, control plane, and data plane. Now, what is this management plane? What is this control plane? And what about data plane? Control plane defines the intelligence of your network. Intelligence means
அவங்க அந்த முஸ்லிம் ஆண்டி வீட்டுக்கு ஃப்ரண்ட்ல ஒரு இருக்குல்ல வீட்டுக்கிட்டே அதுல நோண்டாங்க.
Sir, so sorry. One second, I'll mute the participants.
okay.
Sorry, sir. You can please proceed now.
No problem, ma'am. So what is the difference between management plane and control plane? Control plane defines the intelligence of the network. That means this particular device, let's say device 1, has the ability or capability to take the decision. So why do we consider ourselves as smart? When we have the ability to take a decision that what is wrong or what is right to us. Similarly, for the devices in the networks, if they are said to be smart enough, then that means they are having this capability to take the decision by themselves. So control plane defines the intelligence in which all the rights and permissions are given to them. Whereas if we talk about the data plane, then data plane defines the infrastructure that is used to carry the traffic from one place to another. So previously, this management plane, control plane, as well as data plane, all comprise into your networking devices only. So that was the cause of disadvantages and various obstacles that is coming in its way. So this control plane and data planes are coupled inside the proprietary hardware, which reduces the flexibility, and also they are good to perform the dedicated functions only. For example, if I purchase one firewall, which works on your layer 7. So I cannot make that firewall to work on your layer number 4. Why? Because that is dedicated and that too vendor specific. Okay. So for network administrators, it was very difficult to manage these dedicated functions, plus they are vendor specific. So it was a really tedious job to manage the number of networking devices all throughout the network. So what they come up with, they come up with the idea of SDN. These are all the disadvantages: scalability, cost, flexibility, reliability, complexity. Okay. So they come up with an idea of SDN in which they have bifurcated this control plane and data plane. Now, control plane is in the hands of SDN controller. SDN controller, I'll be telling you about SDN controller in detail in the next few slides. SDN controller is acting as a global view of the entire network, and it is the one who is managing the overall functionality of the network. Whereas this network administrator has a direct bi-directional communication with your SDN controller. That means now network administrator can take a control over your SDN controller, and it can pass on the information from one place to another. Now it does not need, this network administrator does not need to specify or rectify or any kind of modifications to individual networking devices. So in this case, placed in our network, and these routers are forwarding and receiving the information from one place to another. Now this information is getting passed through your SDN controller, which is getting managed by your network administrator. Now what is the difference that you see? Previously, this network administrator has to configure each and every device individually, but now in this case, with the ease of your software defined networking and the basic principle of decoupling of control plane and data plane, now network administrator is just get to involved with your SDN controller only. It does not need to go for the individual routers. Okay. So SDN is a new networking paradigm that is, having this standard principle of decoupling of control plane, data plane. Now with the help of SDN, it is very much easy mobility, scalability, and resilience to their network. And these open source applications are cost effective, and there is no more dependency on the vendors. So no more dedicated hardwares are required. Therefore, it is also increasing the ease of useness and maintenance. This is the architecture of SDN. It is having 3 different layers: application layer, control layer, infrastructure layer. So let us discuss all these layers one by one. Application layer, as the name signifies, it is going to include all the different business applications such as your firewall, your intrusion detection system, intrusion prevention system, and all the relevant SDN applications. The second layer is your control layer. So control layer, as the name signifies, is it is having the centralized provision to control the network, and therefore sometimes it is also called as SDN control layer. So in this control layer, SDN controller resides, and third layer is your infrastructure layer. So infrastructure layer is having this all the network equipments which are equipped into it, such as your core network, routers, switches, base stations, and etc. Now, in order to provide the communication link among all these layers, we have something called interfaces, application programming interfaces, APIs. So in order to provide the communication among your SDN control layer and application layer, we have northbound APIs. And in order to provide a bi-directional communication among your control layer and infrastructure layer, we have something called southbound application programming interfaces. So far, I have already told you that SDN is still an emerging technology. So far, this northbound application programming interfaces are not yet standardized. But on the other hand, this southbound application programming interfaces are standardized. And the most common protocol which is being used for the southbound API is called as OpenFlow protocol. So we'll be discussing this as a case study for OpenFlow protocol in today's topic as well. In the meantime, if anybody is having any doubts so far, then please let me know. Do not hesitate to ask the questions. So this is a comparison of SDN architecture with the traditional architecture, traditional network. So you can see that in the traditional network, we have this control plane and data plane coupled inside the proprietary hardware. Whereas in case of software-defined networking, this bifurcation is done and the provision is in the hands of controller machine present over here. And these are all the programmable switches, which are the dumb switches and used to carry the traffic from one place to another as per the instructions of this controller machine. Now, the most important, the vital element of your SDN architecture is called as SDN controller. So SDN controller is an application in the SDN architecture which manages this flow control for improved network management and application programs. So there are many companies and vendors which are providing their own SDN controllers. And please mind it, all the SDN controllers are open source and freely available over the internet. So one can easily download them and get to use them. So Cisco, VMware, Juniper Networks, Big Switch Networks, Pika 8 vendors, all these are the vendors which are available in the market. Big giant networks, I would say, which are providing these SDN controllers to the companies as well as to the researchers to provide the experimentation and various mechanisms. Now, there are a number of SDN controllers which are already available in the market. So these are the most widely and popularly used SDN controllers, such as your POX, Rio, Floodlight, Trema, Open Daylight, Open Networking Operating System owners. Now, these controllers are written in different programming languages. What is the support for OpenFlow? That I will discuss in the next slide. But so far, I have already told you what is this OpenFlow protocol. OpenFlow between your control layer and infrastructure layer. Yes, they all are open source. Some of them are providing this graphical user interface feature and some of them are not. REST API, most of them are using this REST API except this Fox and Trema, and rest everyone is making use of REST API. Some of them are having this multi-platform support, such as your Open Daylight and Onus, and rest are having one or two platforms to get their support. Vendor support, except your Fox and Rio, all the other controllers are having multiple vendor support. Now let us discuss about your OpenFlow protocol. So I have already told you OpenFlow protocol is acting as an intermediate communication protocol for your control layer and hardware abstraction layer. So basically it decouples your control logic from one place to another. So this is basically the OpenFlow protocol mechanism, working mechanism. You can see here. So in open flow protocol, we have got open flow channel, flow tables, port tables, group tables, and meter table. So this is your one open flow switch. So what are the different entities which are involved in this open flow switch is your open flow channel, table, group table, and flow table. So what happens whenever any new packet coming towards this open flow switch, it has got flow tables associated with them. So let's say a one packet is coming towards your open flow switch. Okay. So that incoming packet is having one source and one destination address. So the destination address that is to be matched with each and every flow table available into that open flow switch. So let's say it has got n number of tables associated with it. So first of all, it will check with your table number 0. If the match is found, then it is okay. It will send that packet to the destination. If the match is found in the table number 1, then it will send that match to the second table. And so on, it will check up to table number n. If the match is found in up to table number 10, then it is fine. Else the other cases, it will create an packet out event. So it will create an packet out event in which it will ask the SDN controller about the changes that it needs to do. Okay. If it does not find that destination of the packet inside the open flow switch, then it will create an open flow packet out event and it will ask the controller to rectify that issue and tell me that where do I need to send the destination packet. Then the different actions which are going to perform is your create, update, delete, or something like that. So this open flow switch is just like an x86 instruction set for the network, and it provides the interface to black box networking mode. Black box means it does not tell the user to go for that changes. Black box means the functionality which is happening inside this open flow switch is not visible to the vendors or the users. Okay. And inside your open flow switch, what are the different functionalities that is happening? That is, it is checking each and every incoming packet with the corresponding open flow tables. Okay. Then we have got separation of control and data plane inside your open flow switch. The data path of an open flow switch consists of all the flow tables and entries available. And also they're having these actions which are associated with the each flow entry. So various versions of OpenFlow switch are also available. OpenFlow version 1.0, and right now the latest is 1.6, but it is yet not released, so it is not a stable version. The stable version is still 1.5 only. They are having this with the pace of time. They're having more features available into that, because previously the very first version, that is OpenFlow version 1.0, is having this fundamental architecture, single flow table and IPv4 protocol. But now in this OpenFlow version 1.5, data packet identification process is also there, and scheduled bundle expression. Along with that, it also supports IPv6 protocol. So these are the OpenFlow basic entries. It has got 3 different entities. Very first one is rule, second one is action, third one is statistics. So rule, every flow, open flow table entries is having some kinds of rules and regulations available, such as what is the IP source address, what is the destination address, is this having this IP protocol available to it, into it, LPv4 support, VLAN ID, VLAN proccing ID, MAC source, MAC destination, everything is available into this rule entity. Then action, what action is to be performed either by your OpenFlow switch or by your SDN controller. So some of the actions are like forward the packet to 0 or more ports, encapsulate and forward to the controller, send to normal processing pipeline, modify the fields, or any other extension that you would like to add for it. That means that extensions are customized changes that one can go for. The third one is your statistics. So statistics means how many packets are already transferred from this particular open flow switch. So packets plus byte counter. Okay. How many packets are being transferred from this particular open flow switch? So it is going to maintain one static count with the help of your byte counter. For example, one open flow switch may have transferred around 1,000 packets. So the byte counter would increase to 1,000 number of packets. Okay. So these are the advantages of SDN, like operational saving, flexibility, improved uptime, better management, centralization, and security. No, security, I would say it is an advantage as well as disadvantage as well. Why I'm saying this advantage and disadvantage, that I will tell you in the next slides. Now, what are the different tools which can be used to perform the experimentation in your SDN? So there is one tool called as Mininet, and Mininet is an emulator tool. Now, you might be, wondering that what is the difference between simulator and emulator? So emulator we use in your SDN, and emulator is acting as an exact prototype in which one can create a rapid prototyping of a network into its own laptop. Okay. So whatever the topologies that they're going to run in your emulator, that is for sure going to run in your real, network equipment as well. So SDN experimentations does not require simulators, because simulators may or may not run that topology into the real world network infrastructure. But on the other hand, your network emulator performs the exact functionality, okay, similar to your real infrastructure. So SDN uses this network emulator called as Mininet, and in the next 5 or 10 minutes, we'll be doing this hands-on session on your Mininet as well. Apart from this emulator, we have got some simulation tools as well, which supports the network prototyping of this SDN. So we have got VirtualBox, we have got VMware workstation, we have got Snot. Snot is an intrusion detection system. Again, it is an open source tool available. Snot.org, that is the website. We have got SFlow. Again, it is an intrusion detection and prevention system. We have got SDNet, we have got NS3, we have got Wireshark, which can be used as your packet analyzer for the real-time analysis of the different mechanisms. Okay. So this is about your network, Mininet network. I will tell you this in your detailed thing. So what are the different current research directions in your SDN? So I have already told you that so far there is one SDN controller, which bifurcates the network into different segments called as data plane and control plane. Now, what if something happens to SDN controller? Okay, that is the only single point of contact. So what happens if something happens to SDN controller? Whole network collapse. So in order to maintain that network configurability, we have multiple SDN controller which can be worked together. So if something happens to controller number A, we have got controller number B and controller number C, which can take over the place and performs the functionality. So how to maintain a cordial relationship among controller A, controller B, and controller C? That is the current research directions. Another research direction is standardization of protocols in East, West, and northbound interfaces. So East and West means when we have multiple SDN controllers. So I have already told you that so far we don't have standardized APIs. Okay. So in order to standardize the APIs, we need to perform some standardization protocols. So one can work on the standardization of East and West bound APIs. Along with that, we can also work in the northbound APIs. As far as concerned to the southbound APIs, the southbound APIs are standardized by your Open Networking Foundation organization. And the most common protocol is your OpenFlow protocol. Another research direction is dynamic load balancing mechanism for multiple controllers. Now, let's say we have got 4 SDN controllers which are available inside your network, and these 4 SDN controllers are taking the load and distributing the load among the network. Now, which SDN controller will take the load by its own, okay, and which another SDN controller will bifurcate the load? So that depends upon the number of algorithms. So one can go with that as well. That how to perform, uniform dynamic load balancing mechanisms for different or multiple SDN controllers. Then I have already discussed with you that security can be considered as your advantage and disadvantage of your SDN architecture. So this DDoS attack vulnerability can be considered as a vulnerable point for your SDN. Why? Because distributed denial of service attack would happen over your SDN controller. Because SDN controller is a single entity which takes the in charge of overall network. It has got the global view. So if any anonymous intruder comes into your network and performs a bombardment of huge network traffic towards your SDN controller, then your SDN controller would stop working. Okay. And if it stops working, your whole network would collapse. So that is the DDoS working scenario. Another vulnerable points in your SDN architecture is depicted in this figure. You can see intruder can come in between the control layer and application layer and can perform man-in-the-middle attack to this northbound API. It can also perform this your SDN controller resides. Then it can also work on this communication link of your southbound APIs, which is your open flow protocol. I have already discussed with you that open flow protocol is having this limited amount of memory. Okay. So what happens if it, forwards malicious traffic and, just fills its or overburden its memory. Okay. So the legitimate traffic that is supposed to be run in the network is also discarded. So that is the one thing. And another thing is links among open flow switches. So links among open flow switches is also vulnerable to DDoS attack. So what are the different types of DDoS attacks which can happen in your SDN architecture? That is your ping of death, SYN attack, HTTP flood, and UDP flood. So what is the motivation behind your SDN? So we have got Internet of Things all over the world. More devices means maximize connectivity. So how they are going to connect it? They are either going to connect it with the help of wide medium or wireless medium. So this wide and wireless medium is exceeding the vulnerabilities of attacks and threats to all over the network. Therefore, the existing security mechanisms are not adequate enough to make use of this SDN-based security into their underlying structure. Why? Because they are not using the industry-oriented SDN controllers. They are vendor-specific, and there are number of other disadvantages that we have already discussed in the initial slides of Mark. Then this SDN is acting as a key role to support it, and it provides an intelligent solution to bifurcate the network into two halves, that is your control plane and data plane. And also it performs this dynamic and cost-effective solutions to perform the security analysis against the threats and have yet not adopted it. So these are the different questions that comes in every vendor's mind, that why we should adopt this SDN as an network element to support the infrastructure. So maybe they are having this lack of training, maybe they have lack of infrastructure. So all these hurdles are coming in its way, but still it is just 5 to 6 years of old technology, but still it's in boom. It's radically the new idea in the field of networking, and many companies, big giant companies, even Google. I have read one article, because this information is very confidential and they are not supposed to leak it. But I have read one research paper, and in that research paper, it was mentioned that Google is also making use of this SDN into their underlying Google Cloud data centers. Okay. If you see any company's name like Cisco, Juniper, IBM, Noag Networks, any other big vendors, you just name them, and they are making use of SDN into their underlying infrastructure. So, any questions so far, students? If you have any questions, then please let me know. Otherwise, I'm good to start with the hands-on session now. theoretical concept is covered from my side. If you fail to understand the concept of SDN, then please let me know. I will brief you. So for this virtual box, what you can do is you can go to this website of virtualbox.org. Divya ma'am, I hope my screen is visible to each and
Yes, sir,
every.
it's perfect, sir.
Okay, fine. So students, you can go to this virtualbox.org, and from here you can go to this download virtual 6.1. The latest version is 6.1, and based on your platform package. Okay. So if you're using Windows, then you can go for Windows host. On the other hand, if you're using them, Mac operating system or Linux operating system, then you get to use this another package. So I'm using Windows. So that is why I have chosen this Windows host package. So when you click on it, the downloading starts automatically. I will cancel it because I have already downloaded it and installed it. Okay. So it's of around 104 MB. Okay. So virtualbox.org. So I have downloaded it and installed it. It just take another 2 or 3 minutes. Okay. Very easy to install. So once you install it, you just need to open it. This is the home page of VirtualBox. And now in this VirtualBox, we are going to incorporate a machine of Mininet. So what is this Mininet? Let me first of all take you to that mininet.org website. Okay. This Mininet is an instant virtual network on your laptop or other PC. So this is a network emulator which creates a realistic virtual network which is having this running real kernel, switch, and application code on a single machine. So we need to download it. The detailed explanation and documentation you can go through on it. Documentation is available towards the right side in the PDF format. Okay, you can download it. Another thing is that how to download this Mininet virtual machine. Then click on this download, and from here you will be getting different options to download. So since I'm assuming that most of you are very much new to SDN, so I would recommend you to go for the very first option, that is Mininet VM installation. Easy and recommended. So once I click on it, okay. So once I click on it, I need to go for Mininet VM image from this particular link. So I'll click on it, and it will take me to this github.com. And from here, we can download this Mininet image. So it's an OVF format. OVF stands for Open Virtual Format. Okay. It's of around 817 MB. So you can download any one of them, no problem. So let's say if I download this Mininet 2.3.0, then it will start. I have already downloaded it, so I'm not going to download it. Okay. I will provide you the link in your chat box, but chat box is not available. Okay, no problem. I'll forward this link to the moderators and they will be giving it to you. Okay. So what you can do is go to mininet.org, and from here you can go to downloads, and then after that you can go to Mininet releases. In the meantime, you are going to install this VirtualBox system, VirtualBox. Apart from that, if you don't want to use VirtualBox, you can also use this VMware Workstation or VMware Fusion for Mac operating system. No problem. Okay. So once you download it, you just need to import it into this VirtualBox. I have already imported it, this VirtualBox. Sorry, Mininet VM machine. I will start it. It is getting started. Okay. So now it is asking for that Mininet login. So Mininet login ID is Mininet and password is also Mininet only. The students and the faculty members who are very much well versed with the Linux, they already know that whenever we want to log in from root, there is one keyword sudo minus us. So with the help of this command, we can log in from your root. Okay. Now we'll be starting with the things. We'll be creating some topologies. So first of all, I will tell you what is this mn minus h. Mn stands for minimal, h stands for help. So when I'm using this mn minus h, this is used for displaying a help button describing the Mininet startup option, okay, which proceeds with this Linux command that should be typed in your root shell prompt. Okay, so you can see the different help commands are there, and you can use that. No problem. So let us go with the default topology now. So let's say I'm going to, okay, I don't need to write now sudo keyword because I have already logged in from your root keyword. Okay. So if I write this command mn stands for minimal topology and hit enter. So you can see as soon as I click on hit enter, this is the default topology and the minimal topology, which is a very simple topology which contains open flow switch and two hosts. So two host name is H1 and H2, and there is one single switch which is associated with both the host, that is your S1. So it also creates the links among your switches and two hosts. And let's say if I want to check it out some other command. So let's say I want to go for net command, net command. What happens in net command? Okay, with the help of net command, it shows that how many Ethernet cables are associated with your different switches. Then we have got another command, which is your dump command. So for dump command, this will show switches and hosts which are listed. Okay. So in this case, how many hosts are available? I have already discussed with you two hosts, H1 and H2. They're having the corresponding IP address from class A, 10.10.10.0.1, and another is host is having 02 address. Okay. And this SDN controller C0, which is a by default SDN controller available, that it's having this IP addresses as 127.0.0.1 and port number 6653 and port ID is 1493. Okay. Another command is your nodes, NODES. So with the help of this nodes command, it is depicting the available nodes in the different topologies. So right now we have created one minimal topology. So in this minimal topology, available nodes are C0 stands for controller, H1 is your host, H2 is your host, and S1 is your switch. Then we have got another command, ping all. Ping all is used to test the ping reachability. Okay. So right now, ping reachability is there. That is why 0% drop is there. And 2 by 2 received means all the packets which are to be transferred from one host to another are well received. Now, let us ping individually. H1 ping H2. So if I use this command, you can see pinging has started. Okay. And the packets are transmitted. Which protocol is being used over here? ICMP, Internet Control Messaging Protocol, and TTL stands for time to live. And for the very first packet, it has taken this 2.58 milliseconds time, and later on, once the connectivity is established, it has just time has reduced. Now to stop this, Control C. As soon as we click on this Control C, this is the beauty of your Mininet emulator tool that respond to time, minimum, average, maximum, standard deviation, everything is calculated by own. So the statistics of this particular experimentation was around 30,999 milliseconds. Okay, 0% packet loss is there. 32 packets were transmitted and 32 packets were received. Okay, and everything was calculated: round trip time, minimum, average, maximum, and standard deviation. Okay, so likewise you can create different topologies, and for the different topologies you can create the experiment evaluation. Then let's go for the next topology, which is your single topology. So in your single topology, what do we need to do? Let me first of all exit from here. Okay, and let me clear it. Okay, so for single topology, what is the syntax? MN topo stands for topology, and we need to mention the topology name single, comma. Now, how many hosts would you require to go for? So let's say I want to go for 4 hosts, then I would write 4. Similarly, in your case, if you want to go for 45, 4, 3, 5, any number that you want to go for, then you mention that number and hit enter. So since I have selected 4, so 4 hosts are available with the help of one single switch. Now, why single switch? Why? Because this is your tree topology. Okay. So you can see here the topology is created and I can ping all, test the connectivity and reachability. I can also ping H1, ping, let's say H4. Yes, it is pinging and show the successful creation of topology. Okay. Let's go for the next topology. Let me exit from here. And for the next topology, we have got linear topology. So for linear topology, what is the syntax? MN. So let's say this time I want 3 hosts, sorry, 3 switches. Okay. And 3 hosts. Since it is your linear topology, so you can imagine the linear topology. What is the difference between linear topology and tree topology? In linear topology, if we happen to choose 3, that means 3 switches would be there and 3 hosts would be there. But in case of tree topology, whatever we are mentioning, that is just indicating for the number of hosts. Because in your tree topology, there would be only one single switch, that is your S1. But in case of this linear topology, we can mention a different number of trees and different number of switches. Okay. Let me now ping H1, ping H3. Yes, they are pinging. Let me stop them. With the help of dump command, we can come to know. With the help of net command, we can come to know a different number of topologies with them. Is it fine, students, up to here? Anybody is having any doubts? So these are some of the topologies today that we have learned. So far, we have done the experimentation on minimal topology. We have seen some of the commands like dump command, net command, nodes command, ping all, default topology, minimal, tree, reverse, linear. Okay. Now let me exit it from here. And to power off this, just need to write down power off, and this machine will be powered off automatically. Very easy to use. I would recommend VirtualBox over your VMware because the compatibility of Mininet virtual machine is very good over your VMware workstation. That is my personal experience. I've been using this VirtualBox since 5 years. So so far I have not found any kind of difficulty to work with this experimentation. And nonetheless, I have also told you about this Mininet emulation tool. And if you want to go for another detailed explanation, then you can go for this various topologies available over here. FAQ is there. Okay. Source code is also there. If any student wants to, make any changes into this GitHub, then you can go for, because it's all not vendor specific. It is all customized changes. Okay, you can go through it. It is easily available over here. And most important, this Mininet is written in your Python language. And some of the SDN controllers like Rio, POX, they're also written in your Python programming language. Okay. So that's all from my side. If anybody is having any questions, anything to ask, then I'm open to questions. Uh, Anybody having any doubts?
So 1 second, I'll just unmute the participants.
Sorry, ma'am.
I'll unmute the participants. So like right now, they're all muted actually.
Okay. Okay, ma'am. Okay, fine.
Okay, so the session is open for Q&A. So any queries you can please ask, sir. Sir, in the meantime, may I request you to kindly share that PPT and the codes that you did so that I can send it across.